All right, so once again, good morning, everyone, and welcome back to another exciting day in mathematics. Whoop, whoop. 6? Okay, thank you. So warm-up number 10 is on the screen. The first one was simplify 7m minus 9x squared plus n 10 plus negative 2m plus 5x squared plus negative 2 minus 5m. All right, what'd you get for this one? Marco. Negative 4x squared plus 8. Hands if you got that. That is correct. Let's go. Now, once again, the practice for this that I've been giving you all week for the past 2 weeks is to check for addition all throughout. Is that correct? And anything that's subtraction, make sure you change it to addition, and whatever's to the right to its opposite. So be careful with those. Number 2. Pablo.
Negative 2x squared plus 3x plus 15.
Hands if you got that. That is correct. Let's go. Number 3. Sebastian.
I got
Solution set.
solution set x plus that negative 5 is less than x less than 2.
Let's go. Hands if you got that. That is correct. 3 out of 3. Now, did everybody catch that by the end of the week you should be able to do these by yourself? On Mondays, I go over it so you guys can remember how to do these, but the rest of the week we're working on them, and by Friday you should be able to do these all by yourself. If you're still struggling with these, revisit the video lesson or come see me so like that you can see the processes. Because today, you're going to see how this practice is going to come to play with what we do today. Okay? Copy the agenda, please. Agenda for today, warm-up number 10. Today we're moving on to polynomials. Let's go. Remember I told you guys that we're never going to get rid of polynomials. You're going to be walking down the street going towards Donut Avenue. Then you hear in the alley, you turn, polynomials. They're everywhere. Today's home play sheet involving polynomials. There's only 12 problems. So could I get the last person on each row? Go get a play sheet. They're over there on top of the cart for your row. All right. So there was no home play last night. You should have just finished the activity that we started here, yes? However, for those of you that are watching online on the video that you were absent, I'm going to include this code for Nearpod. Make sure you write it down, because in there, when you go to Nearpod, from now on, if there's a play sheet that I assign, I'm going to include it in the presentation. So make sure you go to Nearpod, advance to the next slide. It's going to say home play. And then the following slide is going to be a PDF reader, and you're going to see the play sheet in there, okay? So your asynchronous session code is HYCWF. HYCWF. Okay, once again, the play sheet is in there in PDF format, but you have, those of you that are here, you have it in paper format, all right? So once again, your play sheet for tonight, your home play, is going to be only 12 problems, and it looks like this. Make sure you get to that as soon as you get home. Don't procrastinate. If you're going to go to the game, take it with you up there on the stands. Be doing your home play on the stands. No. All right. Y'all ready? All right, here we go. Our objective for today, I can classify polynomials. Once again, I can classify polynomials. So our main concept for today, Marshall, what's our concept for today? Okay, so that's the objective, yes. So the main concept is polynomials. So in your prayer model, you're going to write polynomials in the center. And what are we doing today with those polynomials? We're only classifying. Now today's going to be the day for me to get rid of a lot of doubts for some of you that all of a sudden when you start getting into the Algebra 2 course, this is foundational for you to know. So like that you are able to see it, understand what we're looking at, and we can go on expeditiously with that, yes? All right, so what are polynomials? Here goes some flashbacks for some of you that were with me. Let's see. Polynomials are, let's see. Very good. Monomials, or the sum or difference of monomials. Polynomials are what? Monomials, or sum or difference of monomials. Polynomials are monomials, or sum or difference of monomials. Some of you are like, okay, well, I don't remember polynomials, Mr. Q, and I can't recall monomials as of yet. Well, monomials, all it is, it's an expression with one part or one term. For example, the number 2 right there, write that down, that's a monomial because it's only one part. But it's also known as a polynomial. Let's go to the next one. X squared is a monomial because it's only one part. But it's also known as polynomial, sorry. Look at this one. Negative 3x to the 4th plus 2. This is not a monomial, but the definition says a monomial or sum or difference of monomials. So look, negative 3x to the 4th is a monomial. Then we add 2, which is another monomial. Together, this is a what? Polynomial. Look at this next one. X squared minus 3x plus 2. Let's see. It's not a monomial because this one has more than one monomial. Here's monomial, then subtract another monomial, then we add another monomial. That's why it says sum or difference of monomials. So once again, what are these called? Polynomials altogether. Yes? Now, to refreshing your memory, the word polynomial is a compound word. In Greek, poly means many. Nomial means part. So in that sense, the word polynomial means what? Many parts. Let me repeat that again. Many parts. All right? So, now that we know what polynomials are, we know that it involves many parts or many terms. Let me show you what they're not. Copy that. As you're copying that down, start thinking, these are not polynomials because these are, but why specifically are these not polynomials? All right, so as you're writing those down, share with your neighbor why these are not polynomials and why are these polynomials. Talk it over with your neighbor, please. All right, Justin, why are these not polynomials? They're equations. So what does that make all the polynomials, everyone? Expressions, that is correct. So what would be our first hashtag? Hashtag expressions only, that is correct. But yeah, we're taking a step back. I know we were already in equations and inequalities one variable, but I'm taking a step back because we're about to get into quadratics next week, okay? And what did we say that polynomial was? Monomial, sum or difference of monomials, but the word itself, how can it be broken down? Many terms, so hashtag various terms, or many terms. Whew. Yeah, that's all. Edwin, can you get the door? Please leave it open, please. Thank you. We good up to right there, yeah? All right. So, next. Don't write this down. Write your utensils down. Look up to the screen. I'm going to clarify in regards to terms and parts and all that. So here we go. I'm going to start with terms. Terms of an expression are the parts that are being added or subtracted. That's why each part that is being added is known as a part of the expression or a term. So when I ask you how many parts, I'm not going to say how many parts, I'm going to say how many terms. And how do you know? Anytime you see a plus or a minus, that's when a part starts and a part begins. A part stops and another part begins, okay? Like terms is when you have two terms that have the exact same variable with the exact same exponent. Let me repeat that again. Like terms have what? Exact same variables with the exact same exponents. Example, look up to the screen. Look at this one. How many terms does this have? Let's see. 1, 2, 3 terms. Okay. Which ones are like terms? 4x and negative 3x. Why are they alike? Because they have the exact same variable with the exact same exponent. So yes, these are known as like terms. So what do we call the number by itself? We already covered this. This is known as a constant. Are we there so far? Okay. Next. Whenever you have a number multiplying a variable right next to it, that is known as a coefficient. So look at this expression. What numbers are coefficients? Tell your neighbor, please. What numbers are coefficients? So notice that the 2 does not have a variable. The 4 is multiplying x, and the 3, from now on, I'm going to call it negative 3, is multiplying the other x. So guess what? These are my coefficients. So far so good, yes? And last but not least, if a term or an expression doesn't have a coefficient, then you're going to assume that the coefficient is what? 1. So watch. Look at this. Do you see any coefficients? No. But do we know what they are? What is the coefficient of x squared? And of x? 1. There it is. All right, let's see how we did. Copy this, please. Underneath your prayer model, write parts of expressions. And then write this expression. 6x squared minus 5x plus 4 plus x squared. And then underneath that, instead of writing the whole statement, all I want you to do is write this. We start with, let's see, terms. For the second one, you're going to write like terms and then a blank. The next one in green, constant, and then a blank. And the last thing you're going to write all coefficients and then a blank. So they don't have to write the whole thing. All right. So let's break this down together. Here you go. So I'm going to start, and I'm going to go from left to right. I'm going to start underlining, and whenever I see a plus or a minus, I stop. So here we go. There's a minus, I stop. Okay, so this is one term. Let me start again. There's a plus right there, I stop. That's 2 terms. 3 terms. 4 terms. So there's 4 terms in this expression. 4 parts. Next, which ones are alike? Turn to your neighbor, let them know which ones are alike. All right, who said 6x squared and x squared? Yes, so write that in there, 6x squared, comma, x squared. Those are like terms. Next, by now, what is our constant? 4. So I write it in here, that's 4. Next, what are all the coefficients that you see? Talk to your neighbor and write them in there. What are all the coefficients that you see? Okay, so what numbers are multiplying the variables? Let's see, the 6 is multiplying this one. The negative 5 is multiplying that one. And what is invisible here? 1. So my coefficients are 6, negative 5, and 1. It's coming back, yes? Okay. All right, I helped you with this one to see if you can do one by yourself. So the next one that I give you, you're going to copy it over here. So like that, you don't have to write all this again. Just put another blank like that, and then fill in the information. Ready? Here we go. Copy that one. X squared plus 10x minus 3 minus 8x. Once again, how many terms? Which ones are like terms? What is my constant? And then list all the coefficients. Give you some time for that. Ready? Whew. All right, let's see. Mel. How many terms? 4. Okay. Pass someone. 10x and negative 8x are like terms. Hands if you got that. That is correct. Pass someone. Erica. Constant. Negative 3. Hands if you got that. That is correct. Pass someone. $10, which is this one. Negative 8, which is that one. And 1, which is that one. Hands if you got that. Yeah. Okay. You got this, yes? All right, show me your fingers up to yours, up to right there. Okay. We're about to get on the bike with fire, yes? Ready? Here it goes. So, today we're going to classify polynomials, which means we're going to give them a name. Okay? In the past, some of you struggled with this, and some of you, this is where some of you lost some of your teachers because you didn't understand what they were talking about. So this is imperative or important that you know, because we're about to get into quadratics this coming week. So I'm going to break it down as much as I can. Here it goes. Polynomials have 2 names, a first name and a last name, just like us. Their first name is according to degree, and I'll elaborate on that. And the last name is according to the number of terms it has. Now, I created a table, me, Mr. Q, I made it up, to help us with that, and it looks like this. Some of you are like, oh, I remember this. Yes, copy that, please. We got 1, 2, 3, 4, 5, 6, 7, 8 columns. Then I got 1, 2, 3, 4, 5 rows. Copy that table, please. And at the top of the columns, the first column, title it terms. Then the next column is 0, which is constant. 1, which is linear. 2, quadratic. 3, cubic. 4, quartic. 5th, quintic. 6 or more, and you just see here 6th, 7th, etc. And that's by the degree, that's in red. Over here on the first column, after terms, you're going to write 1 term, that means it's a monomial. 2 terms, that means it's a binomial. 3 terms, which is trinomial. And anything after 3, which is 4 or more, it's known as just a regular polynomial. I'll give you some time to copy that. Go. All right, so what I'm going to do, guys, I'm going to scoot this up a little bit. About right there, and then I'll move it up a little bit more. And remember, the first name is by degree, and the last name is by the number of terms. Once again, the first name is by degree, and the last name is by the number of terms. So I'm going to write down here, and I want you to do the same, example MJQ. So here goes the first example. X cubed plus 5. Just write it down. We're going to do this part together. Okay, here we go. Look up to the screen, writing utensils down. Here we go. You'll finish copying right now. So I need to give this polynomial a name. First, I need to know the highest degree of this polynomial. How do I do that, Mr. Q? Well, look, I start off by circling the first term. What is the exponent on the variable? 3, so this degree is 3. Next, I go to the second term. What is the exponent on the variable? You're like, it doesn't have a variable, Mr. Q. That means this is a degree of 0. My question to you, out of those two, which is the highest degree? 3. That means I go to the degree, look at the 3, and this is a what? So I'm going to label this cubic. Copy that so far. Now that I have the first name, I need a last name. And what's the last name? According to the number of terms. So look at it. How many parts does this expression have? 1, 2. So look down here. What is the name according to two terms? Binomial. So I'm going to label this binomial. So this is called a what? A cubic binomial. You're like, oh snap, I think I remember these, Mr. Q. So far so good, yes? Let's do another one. Let's do, let me scoot this over. And let's do example Shazam Q. Here it goes. X squared plus 5x plus 6. Let's see if you can give me a name for that polynomial. I'll give you some time. Copy, go. Look up. First thing, I need to find out the degrees of each term. So what is the degree of that term? 2. How about this term? 1. How about this term? 0. So what is the highest degree? 2. So I go to 2. So this is a what? Quadratic. It's a quadratic because the highest degree is 2. There it is. How many terms does this expression have? 1, 2, 3. That means how many parts? 1, 2, 3 parts. So if it's 3 parts, it's a what? Trinomial. Trinomial. So this is known as a quadratic trinomial. So maybe the fingers, I'll come to you up to right there. Okay? Now, I'm easing you in. One thing I want you to notice is that I gave you expressions that were already in standard form. From highest degree to lowest degree. From highest degree to lowest degree. What does that mean, Mr. Q? That now I'm going to give you some that are not in standard form, and I'm going to give you some steps to do. Okay? Copy this. Example Q, and it reads, classify the polynomial. And we have 6x, bless you, minus 7x to the 5th, plus 4x squared, plus 9. And there's some steps here I want you to copy on the side and have them handy. First step, it says identify the degree of each term of the polynomial. That's what we just did. Arrange the terms of the expression from greatest to least degree. That's what we do on the warm-ups for standard form. Then the second part there, it says identify the leading coefficient. And I'll show you that in a little bit. And part 3 says classify the expression according to the greatest power and the number of terms. And I placed the table there so we can have it handy. Copy that? All right. So I'm going to leave those steps and the table on the slides as we go through so you can finish up anytime that I give you extra time. So for right now, I want you to put your writing utensils down. I'm going to go over this completely. I just want to make sure that you understand what we're doing with the entire process, okay? Writing utensils down, look up to the screen. Here it goes. I'm going to start with step 1. Step 1 says, identify the degree of each term. So that's when we do this. Here's my first term. What is the exponent on the variable? 1. Second term, exponent is 5. 2, 0. Okay, step 1 is done. Step 2, arrange the terms from greatest to least. So what is the greatest power here? 5. So I start with writing the term negative 7x to the 5th. What's the next term down? Next power? 2. So I write what? 4x squared. What's the next one down? 1. So what do I write? Positive 6x. And what's my last term? Plus 9. So we're done up to right here. Copy that so far? Okay, once again, we identify the degree of each term. That means we look at the exponent on each variable. 1, 5, 2. There's no variable, so this is 0. Arrange the expression according to the highest degree. We start with 5, so this is negative 7x to the 5th. Then 2, that means plus 4x squared. Then 1, that means plus 6x, and at the end plus 9. This, guys, is known as standard form. Okay. Have we been doing that on the warm-ups? Yes. Okay. However, in there, look what it says. Identify the leading coefficient. Write your utensils down, look up to the screen. Before I identify it, first, look at it. What are all the coefficients? Tell your neighbor, what are all the coefficients? All right, let's see. Maritza. All the coefficients are, from left to right, negative 7, 4, and 6. That is correct, because those are the numbers multiplying the variables. So whenever you have this in standard form, the very first coefficient from left to right, which is this one, is known as leading coefficient. Label that. My leading coefficient is what? Negative 7. So we're done with step 2. Last but not least, classify it, which means give it a name. So, look at the degrees. What is the highest degree, guys? 5. So according to the degree, what is the name of that one? Quintic. Because that was the degree. Here it is. Okay. Next, we need a last name according to terms. How many parts do we have? 1, 2, 3, 4 parts. What is that called? Polynomial. All right, show me your fingers. I'll come to you up to right there. Okay. I'm going to give you one for you to do by yourself. You have 4 5s, 4 5s. Here we go. Example super cube. Copy this one. 16 minus 4x squared plus x to the 5th plus 9x cubed. And go through the entire process. Copy that and go. All right. So let's see. Help us with standard form, please, Kevin. Standard form. X to the 5th. 9x to the 3rd. Minus 4x squared. Plus 16. Hands if you got that. That is correct. And once again, step 1, you needed to look at the terms. This is 0 degree, 2nd degree, 5th degree, 3rd degree. Leading coefficient. Jessica, what is our LC? Okay. Before I ask that question, my bad. What are all coefficients? Share with me. What are all coefficients first? What are all coefficients? Okay, I heard 1, 9, and negative 4. Is that correct? Now that we know that they are in order, my leading coefficient is 1 is correct. 1. Because it's right here. It's invisible. Okay? Without saying, name, Nicholas, what is the name of this polynomial? Quintic poly. Hands if you got that. Yes, because the highest degree is 5, which is right there. And since it has more than 3 terms, 4, so it's a polynomial. Okay? All right. So by now we should get this, yes? Show me with your fingers how comfortable you are with these. 5, 5, 5, 4, 5, 4s, and we're fanning ourselves, yes? Okay, I think it's time for a joke. Ready? Here you go. We need to make some humor out of this. Okay, before we continue, and this is going for you guys on the video, enjoy this joke. So once upon a time there was this kid that he thought he was a fan. So anytime he got on the bus to go to school in the morning, as soon as he sat on the seat, he started. And he was blowing. And the lady that was driving, she kept like looking at him, are you serious? Because he sat way in the front with her. And she's all like, oh my goodness. And she thought maybe, you know, day 1's okay. Here goes day 2, same thing. Day 3, day 5, and the same thing, this kid wouldn't stop. So one day, this lady, not to be mean, but she was already like, she wasn't in a good mood that day. And she was going to help another kid off from the bus. And she's all, this kid doesn't stop. I'm going to smack him on my way back, like accidentally. So as she's coming back, she acted like she didn't see him and smack, like right on top of his head. And then he's off. You guys get it? Yeah? He's a fan and then he pushed the button? Never mind. Those that are listening on YouTube, you should see it. Anyways, let's move on. Let's crank it up a notch. Example number 1. 3y minus 7x to the 4th y minus 8 plus 4x squared. Yeah, he started isolating, right? Anyway. Let's do this one together because this looks a little bit different. I get it. But let's go through the process one more time. Step 1, identify the degree of each term. So circle this one. The degree for that one, the exponent is 1. Circle this one. You're like, uh-oh. This one has 2 variables, Mr. Q. What happens when we have a 4 and a 1? You add the exponents on the variable. So this is 5. Next, 0. Next, 2. So with that said, standard form, Marshall, go.
Standard form?
Yeah.
7x.
Negative 7x
4.
to the 4th.
4x.
Y. Okay.
4x.
4x squared
2y.
plus 3y minus 8. This is standard form. Turn to your neighbor, let them know the leading coefficients, please. Leading coefficients. Thank you. Leading coefficient. Leading coefficient. Some of you said negative 7, yes? Yes? Okay. Next. Name. Who haven't we called on in a while? Pick someone, Sebastian. Sky. What's the first name according to degree? Quintic. Thank you. All right. Yes, because the highest degree is what? 5. How many terms does this one have? 4. So this is a polynomial. Let's do another one. Here we go. Copy this one. Example 2. 9b plus 5a squared b minus 3a squared. Go through the process, write it in standard form, identify the leading coefficient, and give it a name. Copy and go. Oh, man. All right. Who went last? Who? Oh, Sky. Pick someone. Who? Izzy? Okay. Standard form, Izzy? What's that? Oh. Giselle? Where's Giselle? No, Giselle? No? Okay. Izzy, help us out. Standard form? Hands, have you got that? That is correct. Pass on one. Leading coefficient? 5. Just a number multiplying the variables. That is correct. Okay. And last but not least, pass someone for the name, first and last name. Who? Let me help them out. This is 1 degree, 3, because that 1, and this is 2. What's the highest? 3, so this is a what? Help them out, guys. Cubic. That is correct. 3rd degree is a cubic. How many parts does this have, everyone? 3, so this is a trinomial. Hands if you got that. Whew. All right, and we have time for one last one? Yeah, one last one, yeah? Here we go, last one. Example 3. 18x y to the 5th minus 3x y to the 8th plus 14x y plus 5x. Arrange that in standard form, give me the leading coefficient, and give it a name, please. Should go a little bit faster this time. So just to help out, this is to the 6, this is to the 9, because 5 plus 1 is 6, 8 plus 1 is 9. This is to the 2nd, and this is to the 1st, yes? Okay. All right, let's see, help us out please. Lynn, what would be standard form? 3y to the 8. 18xy to the 5th plus 14xy plus 5x. Leading coefficient is -3. And this is a, check this out, 9th degree polynomial. Have a good one, guys. Enjoy your home play. Make sure you work on that over the weekend, because next week we're going to get started with more stuff in regards to polynomials. Bye.